Tutorial sheet 1, question 5. And we have this rather horrible looking equation, which is a combination of 3 exponentials, each with a unit step function. So again, what I'm going to do, I'm going to split it into the 3 separate functions and actually plot graphs of each of those functions. So first of all, I'm going to plot a graph of e to the minus t u of t. So we know that u of t when t is less than 0 is 0, so nothing occurs before time is 0, and after time is 0 or time is greater than 0, this just becomes 1. So at this point all we have is an exponential of e to the minus t. So when t is 0, we have e to the 0, which is 1, and then we have an exponential decay curve. Second function which is e to the minus t u of t minus 2. Well, it's still an exponential, so what I will do is I'll still draw this exponential, but I'll draw it at the moment as a dotted line, because we're familiar with what e to the minus t looks like. But of course we have this unit step function, and we know that this unit step function is shifted to time t is equal to 2. And unit step function essentially acts like a switch, so there's nothing occurring before time is 2. And at time 2 it switches the function on, and that has an amplitude of e to the minus 2. The third function we'll plot. So this is e to the t minus 4 u of t minus 4. Well, in this case we've got an exponential function. This is an exponentially rising function, but it's time shifted to t is equal to 4. So nothing's going to happen before time is equal to t equal to 4, similarly because we have a unit step function. So nothing is going to happen before time is equal to 4. And then what's going to happen at this point, we're going to have an amplitude of 1, because when t is equal to 4 you have e to the 0, which is 1, and then that's going to exponentially increase. So we've got 3 functions, and that's going to give us our final rather complicated looking graph for x of t. And we're going to need a few points on this graph. First of all, we're going to need e to the minus 2, which is due to that one. We're going to need 2 e to the minus 2, and we're also going to need 1 plus 2 e to the minus 4. That will become obvious in a moment. So first of all, and we're also going to need 1. Note, these are not to scale. And then we're going to have time 2 and also time 4, because those are the interesting times when things start to change. So first of all, we've got our first function, which is just this one. And that is going to come down to a point of e to the minus 2. So we have 2 points, one here, one there, and we can draw our exponential. I'll draw it better than that, I'll leave try, down to here. So when t is equal to 2 we have e to the minus 2, and these other 2 functions aren't having an influence at the moment. And at this point we've got e to the minus 2 from the first function plus e to the minus 2 from this second function. So that's why we have 2 e to the minus 2. And then that is again exponentially decaying, and it's exponentially decaying to a point where we have t is equal to 4. that particular point is 2 e to the negative 4. Because we can just put these two equations in, put t is equal to 4 in there, so we've got, and that tells us that we get 2 e to the negative 4. We've got e to the negative 4 plus e to the negative 4. And then we've got to add on this function, which is going to be 1 when t is equal to 4, because we've got t minus 4, so we've got e to the 0, which is what this 1 is, gives us this 1, plus the 2 e to the negative 4 that we've already got. So this jumps up, if I line this up to here, and then that then exponentially increases after that.